Hi everyone, in this video I will show you how to use testnet code to super resolve cross-modality brain graphs using brain templates and one-shot learning. This work is published and selected as oral presentation at Prime Workshop yielding MICCAI Conference 2021. In order to start using testnet, we first need to download required dependencies. Then we can start the execution of our framework. First, we need to download the testnet code from our GitHub repository. Then, we need to create a virtual environment using the following command. After that, we can activate this virtual environment using this command. To install the required dependencies, just copy-paste and run the following commands. Our framework uses PyTorch and PyTorch Geometric for neural network tools. Matplotlib is used to visualize the output CBT. Last two packages are required for similar. Note that this is all for CPU installation. Please visit PyTorch Geometric website for GPU installation. Testnet expects two datasets, one for source domain with low resolution brain graphs and one for target domain with high resolution brain graphs. Each dataset has brain networks of NS subjects. These brain networks can be represented as brain matrices. Size of a brain matrix is NR times NR for the source domain and NR prime times NR prime for the target domain. NR and NR prime denote the number of regions of interests in the source and target domain respectively. To run the testnet, we need to vectorize the upper triangular parts of these matrices so that we obtain the column feature vectors for both domains. The output of testnet is a CBT for the target domain with size NR prime times NR prime. To execute the testnet code, first activate the virtual environment, then run Python 3 demo.py. You can execute our framework on a simulated or external dataset by editing config.py file. Also, you can change the hyperparameters such as number of epochs in config.py file. Now I will make a quick demo on how to run our testnet code. You can open up a terminal in the folder that you download from our GitHub repository. First, you need to activate the virtual environment. Then run Python 3 demo.py to execute our framework on a simulated dataset. As you can see, for each fault, it is running on CPU and displaying the discriminator, generator, and L1 losses on the screen for each epoch. Also, at the end of each fault, it is displaying the testing results for this fault. At the end of the execution, you can see the mean testing results across the faults. In config.py file, you can change some hyperparameters such as number of epochs, number of faults, and number of clusters for similar. Also, you can give your model a name. If you are training our model on a simulated dataset, then you can change number of subjects, number of source nodes, and number of target nodes according to your needs. Also, you can train our framework on an external dataset. You can find your created simulated dataset in data folder. The trained models are stored in the models folder. You can see the output CBTs for each fault in the output folder. Also, you can find the residuals here. For more details, you can check our YouTube video on our Basira Lab channel and our code on GitHub by clicking the link below.